Okay, so this is basically the alternative way to take derivatives. There's actually a way an actually fairly simple way to basically take the derivative of any polynomial function. So let's say our function is x to the third plus x squared minus 2x uh plus 6. So let's just say that's our example equation, and that's f of x. Alright, sorry this is not the most professional setup. I'm literally recording this with my phone, but anyway, so yeah, this is our example function, and we want to take the derivative of said function. So generally what you want to do for polynomials is, so for example, on this one, for this first term, we have x to the third. So, and then with polynomials, you basically just do the same thing for each individual term. And then you basically just keep the same sign as like addition or subtraction as if they were in the original function. So with x to the third, usually what you want to do to take the derivative of this term. So you'd subtract 1 from the exponent, and then you multiply the term by the original exponent. So that turns the x to the third power into the x to the third term into 3x squared. And you can repeat that process for the rest of the terms. So x squared has 2 as the exponent, so, and it's also addition, so it's plus 2x, and then 2 minus 1 is 1, so we don't put an exponent here. And then same for here, so the negative 2x actually just turns into negative 2, because well, the exponent is 1. 1 times negative 2 is 1, and then 1 minus 1 is 0. So therefore, the x to the 0 turns to 1, and we just left with negative 2 here. The plus 6, when taking the derivative, it really doesn't matter what this last term is for the polynomial, because with literally any basically any polynomial, the constant term will always just pretty much disappear, because you have an x to the 0 basically here. 0 times 6 is 0. So that's basically why it goes out like that. And then one way we can basically try to prove that is basically we can put it potentially into Desmos. So this would be our f prime of x, which, as he said in class, basically f prime of x, like the derivative, it shows the slope of each of the original function. So I'm just going to go over to Desmos for a hot second. Okay, so from there, we have our original function right here, along with our derivative right here. So from there, we can basically, we can see here's our original function, and it basically looks like this. Alright, so, and then here's our derivative, which, as you can see, it basically has the, it has roots basically where, as you can see, these two x coordinates, they match up, basically telling us that the original function has a maximum at the same point where the derivative has a 0. Meanwhile, over here, on the other hand, we have that x-coordinate, and which actually matched up with this x-coordinate right here, basically showing us again that we have a minimum where there is a root of 0. And this basically tells us where the this basically further shows us that the derivative is indeed showing us the slope of the original function. And I hope that's a bit less confusing for you than the monstrosity he taught us in class. So hopefully this helps. Bye!